The day has come for the legendary slope-intercept form. This is going to be one of the most famous equations you ever learn in math. Let's jump right in. What features of slope-intercept form, what are the features, and how do I use them to graph lines quickly? That's right, today is kind of a shortcut approach. This is a famous one, so yeah, it's a famous one. Slope-intercept form. All right. If you have the y on a side by itself, then the coefficient of x is the slope. Remember that m represents slope. The b, the thing that's added on at the end, or the constant term as we call it, is the y-intercept. Okay? So if you have the y isolated on a side by itself, then you have y equals mx plus b. The coefficient of x is the slope. The other term added after the x or subtracted is the y-intercept. Let's do some examples. First of all, I want to graph this equation. Let's start by identifying the y-intercept, because the y-intercept is going to function as our starting point. Now you know from y equals mx plus b that b is 4. This 4 is our y-intercept, and so I can put that point on the graph here. It's intersecting the y-axis. Awesome. Here's why that makes sense. If I was doing intercept method, I'll just show this once. You don't have to do it any other times. I just wanted to justify it for you. If I plugged x equals 0 into the equation like I would do in intercept method, wouldn't this term, when I plug in 0, wouldn't this term go away? Because negative 1/2 times 0 is 0, and I'd be left with y equals 4. So this is the point 0, 4. Oh, hey, this is the point that I graphed. So that's why that number added on at the end is the y-intercept, because when you plug in 0, that's the only number that's left. Next, I'm going to go from this point, I'm going to look at the rise over run. This is a slope, and we know that slope is rise over run. We also know that it is negative, so I should have a falling line as I go from left to right. So to apply the rise over run, I'm going to go down 1, that's my rise, over 2, that's my run, down 1, over 2, down 1, over 2. I can also go in the opposite direction. Instead of thinking of down as the negative, I can go up 1, left 2, because left is also negative. So this has created a bunch of points. Here we have a line, we can connect them. There's no domain here listed, so I'm going to draw arrows and extend the line forever to infinity and beyond, if you've ever seen Toy Story, okay, example 2. So again, I'm going to start by graphing my y-intercept. In this case, the y-intercept is negative 2. So there's my starting point. Nice, y-intercept, negative 2. From there, the slope is 3. Now I only have 3 right now. I don't have a rise over a run because this isn't a fraction. But remember, you can turn any integer into a fraction by putting it over 1. And now I can see that it is a rise of 3 and a run of 1. Since this is positive, my line should be rising as I read from left to right. So I'm going to go up 3, that's my rise, over 1, that's my run. Up 3, over 1, up 3, over 1. I can also go double negative, down and to the left to go in the opposite direction, down 3, left 1. In any case, this gives me a collection of points that I can graph. Let's extend that line the whole way through. There we go. See how easy this is? It's kind of fun. I like it. Here's an example that many people get confused about. It's just y equals negative x, and people are like, what? Where is everything? Where's the y-intercept? Where's the slope? So we need to discover them. First of all, remember the y-intercept is the thing that's added on at the end of the equation. We have y equals mx plus b. What's added on here? Nothing? So 0 is added on at the end. So that's my y-intercept. If I don't see a y-intercept, I know that my y-intercept is 0. But also, I don't see the slope. That's not good. What invisible number, though, can I write in front of the x that doesn't change it? 1. So really my slope is -1, and I know that it's -1/1 if I turn it into a fraction. So rise of -1, run of 1. So in other words, down 1 over 1, down 1 over 1, down 1 over 1. And I can go in the opposite direction, up 1, left 1, up 1, left 1. In any case, these points make a nice line through. Done. Easy. One last example. Now, look at this. Do I have this in the form y equals mx plus b? Is y by itself on a side? No, it's not. And so before I graph this, if I want to graph it in slope-intercept form, I need to work on doing what is called isolating the y. And we practiced isolating the y last chapter. You know how to solve for y here. To solve for y, I need to add 12x to both sides. That will cancel it here. So I have -4y equals 12x plus 2. All right, so now to continue isolating y, I'm going to divide by -4. And remember, that means I divide everything by -4. So this cancels. I have y equals, let's see, 12 over -4 is -3. I'm going to write it as 3 over -1 because I know that I'm going to have to use the slope eventually. It's rise over run. And then 2 over -4 is minus, you could either do 1/2 or I'll do 0.5. Now this is in y equals mx plus b form. See it? The y is by itself. Here's my b. Here's my m. So I'm good to graph this now. Again, we're going to start by the b. Don't get freaked out by the fact that it's a fraction. 0.5 is halfway in between 0 and -1. So there's my point. From there, I have a rise of 3 and a run of -1. Or in other words, my line is going to fall as I read from left to right. So I can either go up 1, 2, 3 over 1, left 1 because of the -1, or I can go down 1, 2, 3, right 1. And I just graphed a couple points that work, so let's connect my line through there. Nice. So how did I get the line in slope-intercept form? I isolated the y. You'll get really good at isolating the y this chapter if you weren't good at it last chapter, because we need to do it a lot because slope-intercept form is really, really convenient. Much like my YouTube videos are convenient. Here's your summary for the period. Remember, y equals mx plus b. It's called slope-intercept form, and the reason it's called slope-intercept form is because it gives you literally the slope, m, and the intercept, b, as long as y is on a side by itself. Thanks for watching.